Hi, I'm an old guy and I do maths and I really enjoy a good puzzle, and here is one. So the function of x is a into x plus b to the power of 5 plus c, and it expands to this. 2x to the power of 5 minus 10x to the power of 4 plus 20x to the power of 3 minus 20x to the power of 2 plus 10x plus 2. And the question, as it was set, and this was a question given to a pupil of mine, was to find A, B, and C. Now, where do you start? Well, when I looked at this, I thought to myself, what I've got here, just in this space here, is I've got a binomial expansion raised to the power of 5. And when I look across here, I see what I take to be the sort of pattern that you get with coefficients as you move through a binomial expansion. Now this was to the power of 5, so what I did was I got out my Pascal's triangle and I worked my way down to the 5th order of this thing, where the coefficients here, 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 and possibly here. We'll come to this later because this is a complicating factor. For the moment we're just going to concentrate in here. The coefficients are 1, 5, 10, 10, 5 and 1. Now that immediately makes me think that perhaps I'm dealing with a dilation factor of 2 here, and I'll test that hypothesis in time. But if I am dealing with a dilation factor of 2 here, then this fits that pattern almost perfectly. 2, 10, 20, 20, 10, 2. And again, be careful about this. When divided through by 2 gives me 1, 5, 10, 10, 5 and 1. There are some features to be aware of. We've got a negative here and a negative here. And I note we don't have a negative here, which would probably make me feel more comfortable, but then I see that we have this thing here, which may well be a positive number large enough to make this positive. So let's take a look at what the binomial expansion of x plus b to the power of 5 would look like. And I've got it here. So 1, 5, 10, 10, 5 and 1 are my coefficients, and note these are positive all the way through, and I have a negative and possibly a negative here. Now I've marked the negatives here and here, and I've put a question mark at the last one because I don't know what C is, and it's entirely possible that when I make my choice that I'll get a negative over here, a negative in here, and from that I can deduce what C would be. It'll be the difference between the negative and this. Okay, that's a lot of talk, but let's just go through this. So when I expand this according to binomial theorem, and I should say here right now, if when I talk about binomial theorem you don't know what I'm talking about, you probably need to go away and, well, actually not go away, have a look at another video on this channel that explains binomial theorem. It's a way of expanding things like that without all the drama that you normally get with expansions. So how does it work? Well, we get our coefficients, line them all up. We take the x, and in this first expression, we raise it to the power of 5, then to the power of 4, then to the power of 3, then to the power of 2, then to the power of 1, and then to the power of 0. We take our second, in this case, pro-numeral in here, and we do the same thing, but we do it in the opposite direction. Start at 0, b to the 0, b to the power of 1, 2, 3, 4, and 5. Now, that makes me think, if a is equal to 2, then if I put a 2 in front of this and bracket everything, I should, and indeed I do, get 2, 10, possibly negative 10, 20, possibly negative 20, 10, and 2. But if I've got these negatives here, I think that this number here has to be negative. Because if it were not negative, if it were positive, I would have positive numbers all the way across here. And if you look at this expansion, every second one is negative, just ignoring that. Now, why is this negative? Well, it's because in this position, b is raised to the power of 1. And here, where it's positive, b is raised to the power of 2. So, my hypothesis as it stands is that this is 2 and this is negative. What is the value of this? Well, if this is 2 and all of these numbers are simply 2 times the prospective coefficients, then this number here must be 1, because it has no effect on these values once it's raised to various powers. The only effect it has is here and here, where things are negative, and these powers are odd. And when you raise a negative number to an odd power, you get a negative result. And that's what's happened here. And so I think that this is 2 times 5 times negative 1. I'm going to test that hypothesis which you see here, that this is 2 and that this is negative 1, and we still have to worry about this. Now, here's the test. Over here, I've expanded this according to binomial theorem with negative 1 in here, and what I get is 1, 5, but it's negative, 10, positive, 10, but it's negative, 5, and a negative 1 over here. And note, I've got C over here with a question mark, because C is going to act upon this finally. All we're interested in at the moment is the binomial expansion of this. Now, if I expand this, what I get is I get 2x to the 5 minus 10x to the 4 plus 20x to the 3 minus 20 x squared plus 10x minus 2. Now what I've done is I should have said that more clearly. I've multiplied this through by 2. Now, this corresponds exactly to this, but for one feature, this. Now, in the order of things that we do, when we deal with an expansion, first of all we would deal with this, then we would multiply through by 2, and we get to this. And so we're at the point where we have expanded this and got this, when what we want is everything here but that last thing to be plus 2. How would we make that so? Well, if this is the expansion of this, and we get -2 and we want +2, we need to make that number equal 4. And then we have what we started with. And so I think that A is 2, that B is -1, and that C is equal to 4. And that is how I did this. It may not be the way that everybody does it, but I saw an opportunity sitting in the middle of that that function with that expansion, and I thought that I could use that. So I hope that this was useful and interesting. If it was, please like and subscribe, and I will see you next time. Bye.